Hey there. Today, we're going to gently pull back the curtain on a really powerful way of thinking through problems. Now, it's got a kind of a big, fancy name, dynamic programming, but honestly, at its heart, it's just about being clever and not repeating yourself. So let's quietly dive in.
So, let's start with a question. Picture a puzzle, but one with just a staggering number of possibilities. How in the world do you find that single, perfect solution, the absolute best one, without getting completely lost?
It's kind of like trying to find the quickest way to drive from one city to another using a huge, complicated map. One with hundreds, maybe thousands of different roads and intersections. The number of possible routes you could take is just massive. That's exactly the kind of thing we're talking about.
Now, what's our first instinct when we face a problem like that? Well, a lot of us might reach for a common sense strategy, but it has this one little hidden flaw that can make it, well, really inefficient.
A really classic way to solve big problems is called divide and conquer. You just take the huge problem and break it down into smaller, bite-sized pieces. You solve all those little pieces, and then you stitch the answers back together. It makes total sense, and a lot of the time, it works great. But not always.
So here's the catch. This approach starts to fall apart when those little subproblems aren't really separate, when they overlap. And when that happens, your algorithm starts acting like this forgetful little robot. It solves the exact same tiny puzzle, but then forgets the answer and solves it all over again from scratch the next time it pops up. And that's where things get really, really slow.
So, how do we help our forgetful robot? The solution, it turns out, comes from two really simple but kind of profound insights. These are the two key ingredients a problem needs to have for this more elegant solution to work.
The first aha moment is just noticing. It's that moment where you realize you're doing the same work over and over again. You see that you're asking your algorithm to solve the identical small problem again and again and again. This property has a name: overlapping subproblems.
Just think about that for a second. All that repetition. Okay, and the second big idea is what makes this whole thing possible. A problem has what's called optimal substructure. It's a bit of a mouthful, but all it means is that the best solution to the big problem is made up of the best solutions to its smaller parts. It means we can trust that if we solve all the little pieces perfectly, they'll build up to a perfect solution for the whole thing.
It's like knowing you have the perfect building blocks.
Right, so when a problem has both of those things, overlapping subproblems and optimal substructure, we can use this special technique. We can use dynamic programming. And really, all that is the simple art of remembering the answers to puzzles we've already figured out. So here are the 4 formal steps that turn this art of remembering into a real method. First, you just try to understand what a perfect solution would even look like. Second, you come up with a way to define the value of that solution. Third, and this is the magic part, you actually compute the answers, but you do it from the smallest problems up, and you save every answer. And finally, you use all that saved information to build your final optimal solution. It's just a clear path to make sure you only solve each little puzzle one time.
To really get what dynamic programming is, it helps to see what it's not. Let's compare it to something called the greedy method. A greedy algorithm is impulsive. It just makes whatever choice looks best in that split second, without thinking about the future. Dynamic programming, it's more thoughtful. It takes the time to solve all the little subproblems first, and then it makes a choice based on knowing all those perfect little answers.
And this slide shows that difference perfectly. This is the knapsack problem. You want to fill a bag with items to get the most value, but you can't go over a weight limit. A greedy approach would immediately grab item 1. It has the highest value for its weight, right? But look, the truly best solution is to take items 2 and 3 instead. That greedy choice, the one that looked so good at first, actually prevented the best possible outcome. Dynamic programming would have figured that out.
So, after all of that, what's the one simple thought to hold on to? Please don't let the fancy name or the 4 steps make it seem complicated. The core idea is actually wonderfully, beautifully simple.
This is it. That's the whole thing. It is a strategy built entirely around efficiency. It's about being smart enough to solve each piece of a puzzle just once, remembering the answer, and then using those answers to build something bigger.
It's a technique that takes problems that seem like they would take forever to solve and makes them manageable, all through the simple and, I think, elegant power of just remembering. Thank you so much for spending this quiet time with me.